Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In today's session, I want to go over the surface area of like 3D shapes. So yesterday, we discussed the area of regular shapes like a triangle, a rectangle, a parallelogram, a trapezoid. And now we are going to take it a step further and say, now I have a shape that is a 3D, like a rectangular prism, for example. Okay, so the base here is a square and each side is a rectangle or a cube. So like if you I should have wrote a die or a Rubik's cube, you have that these shapes also have six identical faces. So if you have a Rubik's cube, you have like the red and the orange back to back, the white and the yellow back to back, and the green and the blue back to back. There are six, and each of the one of them is, so if we talk about a cube is made of six identical faces. So I'm not going to draw it to scale, just to show you what I mean. So this face is a square. There is a top and a bottom shapes. They are squares also. They are one in the front, one in the back, one on the right, one on the left. So altogether, we have six faces. If you count them, you can get the one in the front is one, the one in the back is two, the one on the right is three, the one on the left is four, the one on the top is five, and the one at the bottom is six. Now, if I say that each side is 5 centimeters, so I would say, okay, the area of a square, we already learned that yesterday, or you already know it. I didn't mean learn it, but we reviewed it yesterday and we talked, what is the meaning of area? Remember when we had a small square and we say it's a unit square and how many can fill the face? So we say area of one face, so to speak, would be 5 times 5 equals 25 square centimeter. And since I have six identical faces, then the area of, or the surface area of a cube equals 6 times the 25 or 150 square centimeter. Now, instead of that, if the height wasn't 5, so if I have a rectangular prism, so something that maybe I extend that down here. And I say, okay, the base is still 5 by 5, but the height here is 10 centimeters. So how do I find the surface area of that rectangular prism? Okay. Again, I have two identical faces, two squares, so surface area of the rectangular prism equals, I have 25 on the top, 25 at the bottom, so 25 times 2. If the base wasn't a square, if it were a rectangle, then of course we will take one like that. The calculation will be slightly different, but this one is easy because now all four faces, right, left, front, back, all of them are rectangles that have the same exact dimensions, a base of 5 and a height of 10. So I have four rectangles. Each one of them has a base of 5 and a height of 10. If the base wasn't 5 by 5, so if that was a 5 and that was a 7, then the front and the back would have been 5 times 10. The right and the left would have been 7 times 10. That's the only difference. But since I just extended the cube, then we have the base is a square and the four rectangles would be identical. So this is 50 and this is 200, like 4 times 5 is 20, times 10 you add a 0. So 20 plus 50 is 250 square centimeter. And that would make sense. Why? Because I doubled the height. The height of the cube was 5, but the shape was the same, like a square that was a square all the way. So we said 25 times 6, right? But here, instead of saying, so the area was 150, 25, 25 and 25, 50 for the bases and 100 for the sides, the lateral, right? Now, since I doubled the height, then the area, the lateral area has also doubled. It's the same base, but I doubled the height. So instead of 100, I would get 200. And then 200, the 50 stayed the same because it's the same two squares. Again, that's not a big deal. Let's go now and get some examples here from this website. It says, find the lateral area of each figure and round it to the nearest tenth if necessary. When they tell you lateral area, doesn't mean the surface area. It means just the sides. Okay, so these faces, notice I have 1, 2, 3, 4, 5, 6. That's a hexagon. It has 6 sides. So they want 1, 2, 3, 4, 5, 6 faces. They don't want the top. They don't want the bottom. If they want the top and the bottom, they have to give you more information. And at your level, it's still too complicated unless they give you. We'll see. Maybe we see an example like that, but this one would be a little hard for you. Okay, so what we have here. Well, I think they give you this height from the center of the hexagon to the base. So why didn't they ask for, yeah. Okay, it doesn't matter. This thing is irrelevant, really. They tell you the side is 10, and it's a regular hexagon, meaning all the sides are 10 and the heights are 11. So since I have 6 faces, and these 6 faces would be rectangles, and the area of each rectangle is 10 times 11. So the lateral area of this hexagon, like a hexagonal prism, so to speak. It's a prism with the base and the height. I'm sorry, the top and bottom are hexagons. And the area of each one, so first of all, I have 6 of them. That's the meaning of hexagon. And each one is 10 times 11. 10 times 11 is 110, times 6 is 660 square feet. I still don't see why they give you this and they ask for the lateral area. I don't get it. But anyway, that's extra information. The lateral area here, it's still 10 times 11, but that's a pentagon now. It's a regular pentagon, meaning it has 5 faces. So instead of saying 6, it would be 5 times 10 times 11 equals 550 square feet. The next two are cylinders. And how do we find the lateral area of a cylinder? Maybe in one of my previous videos, let's get the same page, the same sheet we had here. And I'm going to tell you exactly what I said there. Here, if I want the lateral area, I'm going to say, okay, suppose this was made of like cardboard or paper or something. So you made it, or with like aluminum. uh, uh, like can, okay? And then you bring scissors and you cut it like that, open it, and then spread it open. What will happen? This cylinder would become a rectangle. Do you see that? If you have a cylinder like that, exactly, that's a cylinder, and I cut it open and spread it, it becomes a rectangle. Now, the height of the rectangle is the same as the height of this can, which is 7 feet. But who can tell me what would be the length of the base? Think about it. You should get it easily. The length of the base is the perimeter of this circle, right? Because when you open it, and this is 2 pi r. R is 8, so this is 16 pi feet. So the lateral area here becomes 7 times 16 pi equals 112 pi. And then since they want it to the nearest 10th, if necessary, of course, here it would be necessary, you would say 7 times 16 or 112 pi. You get 351.85. And since we are rounding to the 10th, that becomes 351.9 square feet. Here it's the same idea. So I don't know why they repeat it. This is the lateral area. Would be 3 is the height, 2 pi r, which is 2 again, 2 pi r is the base. So you get 3 times 2 is 6 times 2 is 12 pi. I'm sorry, 12 pi, or 12 pi is 37.7 square feet. So that's the lateral area. Now, when they ask you to find the surface area of each figure and round it to the nearest hundredth if necessary. Okay, how can I find the total surface area? It means the lateral area like I did before, but then the top and the bottom. How do I find the top and the bottom? Who knows? That, I think, will need okay. So do you see that if I join the center, this is the center of the base. So the distance from here to here, or from here to here, or from here to there, to each one of these 5 apex or apices is the same. Okay? So now I made 5 identical triangles, right? 5 at the bottom, 5 at the top. So the surface area equals, first of all, I'm going to calculate the lateral area and then add the top and the bottom. The lateral area, like we see, here we have 5 faces, and each face is 11 times 12. 11 is the base of the rectangle, and 12 is the height, and 11 miles and 12 miles. So times 11 times 12. That gives me the lateral area. Now to find the base or the height, the base or the top, I have a triangle. In fact, 10 of them, 5 at the bottom, 5 at the top. So I have 10 triangles. Each one of them, its area is 1/2 base, which is 11. Remember, this is 11, 11, 11. And the height is 7.6. And that gives me the surface area of that pentagon or pentagonal prism. 60 times 11, this is 660. And you say same as that? Yeah, because that was 6 and this was only 5, but the 10 became 12. If you do the math, you will get the same exact thing. 3.8, when you divide this, so 4.18, 41.8. Now let's do the calculator. 5 times 11 times 12 plus 10 times 0.5 times 11 times 7.6 equals 1,000, because that's 418 and I wrote it 41.8. That's what I thought. 1,078 square miles, or mi square. And finally, on this page, I have a rectangular prism. So that's not the same as what we did here, because here the base was 5 by 5, but here the base is 9 times 7. So let's see. Here, what we can calculate is 2 by 2, meaning I have two faces. Think about it: front, back, right, left, top, bottom, and take each one. So you say 2, and then, for example, we take right, left. The right or the left are 7 times 10, so times 7 times 10. And then I have front, back, 9 times 10, so 2 times 9 times 10. And finally, I have top and bottom. The top has a base of 7 and a height of 9, so plus 2 times 7 times 9. This is 140, this is 180, and this is 126. So 306, 446 square inch. Again, 2 times 7 times 10 plus 2 times 9 times 10. It's better to do it to the calculator. And you get 446 square inch. Okay. So now we saw, if they ask you for the lateral area, you just like exclude the top and the bottom. If they tell you surface area, you have to do everything including top and bottom. There is another page. I don't know if we can, yeah, we can do those. I think the top are similar to the bottom, but anyway, it's the same thing, but let's do it. I have 1, 2, 3, 4, 5, 6 hexagon, the base and the height. So first of all, I have 6, so surface area. Notice here they still want the surface area. So I get 6 times each rectangle. And since it's a regular hexagon, then all the faces are congruent. The base is 6 and the height is 7. So 6 of them, 6 times 6 times 7. And then again, I can construct a triangle, and I have 6 at the bottom and 6 at the top. So they are 12. The base of each one is 6, and the height of each one is 5.2. And that gives me the total surface area. I can do it very fast by noticing that these faces are identical, so there is no reason to calculate each one separately. It's one and for all, same thing. If that's a hexagon, I can divide it into 6 congruent triangles, and each one of them has an area of 1/2. Did I multiply? No, I said 12. I'm sorry. Over 2, because that's 1/2 base times height. So base is 6, height is 5.2, and I have 12 of these, but you have to divide by 6, of course. So this is like 36 times 12.2, right? Calculator. They want it to the nearest 100th. So I get 6 times 6 times 7 plus 1/2. 12 over 2 is 6, so 6 times 6 times 5.2. And you get 439 0.2 or 0.20, since they want it to the nearest hundredth, square inch. Going to the last one, same exact idea, but that's a pentagon. So I will have five triangles in the base and 5 triangles on the top. It's regular pentagon. So I have 5 identical rectangles. So 5, and each rectangle has a base of 12 and also a height of 12. And then I have 10 triangles, 5 at the bottom, 5 at the top. So plus 10 times 1/2, base is 12, height is 8.3. So just look at the shape. Sometimes they give you that as a net. So it's the same thing. In fact, it's easier because they will spread it out for you, like we did with the cylinder. Okay, so they will show you 5 rectangles and then a pentagon on the top and pentagon at the bottom. So in fact, it makes it easier. So equals, we get our calculator. You get 720 and 60 times 8.3, which is 40, yeah, 490.2 something, 0.4. Okay, 694, I don't know. 5 times 12 times 12 plus 10 times 1/2 is 5 times 12, 60. So 492, right? So altogether, I get 1218 square miles. There is no decimals again. So I don't know why they say if necessary, and none of them is necessary. Okay, find the surface area of the figure. So we can say the surface area here. We learn how to get the lateral area, right? It's the height is 6 in this case. The base is 2 pi r. Notice here they didn't give you the radius. They give you the diameter as 6 kilometers. So the radius is 3. And that will give you the lateral area. And then you have 2 circles. Each one of them has an area of pi r, which is 3 square. So again, they want you leave in term of pi, so we don't need to substitute for pi. So here I get 1236 pi, and 9 times 2 is 18 pi, so it's 54 pi square kilometers. Okay, the last one, same thing, surface area. When I open this, it becomes a rectangle. It has a height of 3 and a base of 2 pi times the radius, which is 4. This time they give you the radius, not the whole diameter, times 4. And then I have 2 circles, one on the top and one on the bottom. The area is pi r square. 4 times 3 times 2 is 24 pi. And 4 squared times 2 is 32 pi, for a total of 56 pi yards square. And that's basically it. Okay. Should I stop here? No, I think I have other stuff to show you. So for example, what if you are given a rectangular or a triangular prism? Like this one is a rectangular prism. And it's not regular, but this face, the one on the right, CED, and B or AEB, they are congruent, and the one on the face, which is ADE, and the one on the back, which is BCE, are also congruent. And you can see that from here, because this is 90 centimeter and that's 90. This is 1.2, meaning 120 centimeters, and that's the same. Now, I have a triangle. I don't have a triangle. But let's say I have a triangle. Let's assume this is a triangle. It was like that, and I tilted it to be slanted. Did the height of this, assuming this was a triangle, not a rectangle, okay? Did the height change? No. It doesn't matter if it's slanted, but that's the height. Meaning if I turn this a little bit and make it upside, the height, this E to this point would be the height. So really, I didn't change the height. And if I want to find the surface area here, I say the surface area. First of all, I have a rectangle at the bottom, and its area is 90 centimeters times 100 and, oh, let's make it 120 to make it both in centimeters, because 1.2 meter equals 120 centimeter. In fact, the word centi, like a cent, meaning I have 100 of those in 1 meter. Like I have 100 of cents in a dollar. Okay, so the word centi means 1 out of 100. The word milli means 1 out of 1,000. Micro is 1 in a million, and so on and so forth. You can go nano and pico, and you can do whatever. On the other hand, kilo would be 1,000, right? And then mega, giga, and like tera, like you are using, say, with your memory, you know that it goes by an order of 3. But nevertheless, we found the area of the base, and then I have 2 faces that are triangles. So 2 times 1/2, because the area of a triangle is 1/2 base times height. If I start with this face, I have 2 of them, and the area of this triangle is 1/2 times base times height. Notice that the 2 and the 1/2, they always cancel if they are 2, so I don't care about those. And then I have 2 front and back. 2 times 1/2 base times height. Again, this should be 382 centimeter, and this is 380 centimeters, so times 380. That number would be large because it's in square centimeters, not meters. Okay, so I have 90 times 120, which is 10,080. Oops, times 120. Plus, notice the 2 and the 1/2 cancel. So all what I have to do is to say plus 90 times 382 plus 120 times 380. And as I said, it's a huge number, 90,780 square centimeter. Very simple. Break it down into two congruent triangles, 2 other congruent triangles, and a rectangle. I think we had, did I print anything that was, unfortunately, all of them were like rectangular prisms. Or rectangular in the base. Okay, I mean, we can do it, but this one is, all 4 triangles are identical. So surface area is area of the base, which is 8 times 8, plus 4 congruent triangles. Each one has an area of 1/2 base, which is still the same as 8 times height. Notice they tell you it's perpendicular to the base. It's not slanted. This line is slanted, but this one is perpendicular, but I just took the whole triangle and tilted that. So times 10, it's 64. 1/2 times 8 is 4, 16, 160, for a total of 224 square centimeters. Finally, I don't know if you covered that or not. You covered it in volumes, which we will do tomorrow. But how about the surface area of a cone? Okay, the surface area of a cone is basically the surface area of the cone equals area of base plus lateral area, of course. But the way, how do we find the lateral area? Be careful because sometimes they may give you the height to confuse you. We are not going to use the height. This is 2 square root of 7, but I don't care about it. But I'm assuming they give you that because some students will take the height because they are always thinking that, oh, we multiply base times height or whatever. No, here the surface area, the area of the base, that's a triangle, that's a circle with a radius of 6. So it's pi times r squared. The lateral area is pi or the slanted length, 8. You multiply by 8, not by the vertical height. That's a common mistake because we are going to use the height tomorrow when we calculate the volume of the cone or the pyramid, like the pyramid we just did. So for the cone and the pyramid, for the volume, we multiply by the height. But when we calculate the surface area of a cone, we multiply that, the pi r, not 2 pi r, just pi r. Think about it like the bottom is 2 pi r, the top is 0, and you take the average. So it's 2 pi r plus 0 divided by 2. It becomes pi r times L, not height, times L, which is 8. 36 pi, and this is pi times 6 times 8. So 36 pi plus 48 pi equals 84 pi square centimeter. If they ask you to evaluate it, all what you have to do is to multiply that by pi. They ask you for 2 decimal or 100, the nearest 100, it becomes 263.89 square centimeter. That's the most important. If you have covered the cone, I'm not really sure. I don't know which grade you are, like 7th or 8th. So some people may have covered the cone, others may not. So if you haven't covered it, just ignore that until you cover it. But if it's part of your curriculum, meaning you can get it in the test, be careful because they may give you this and tell you, find the surface area as well as the volume. So when you find the surface area, you would be multiplying pi r by the slanted height, which is this line. It has a name, but you haven't covered it yet. But when you do the volume, you will get the 1/3, we'll do that tomorrow, the area of the base times the height, not the slanted length. So be careful on those. I think that concludes what I wanted to cover, like regular shapes also. But now we learn how to find the surface area, how easy it is. You just visualize how many faces. Are they all congruent, or some of them, or every two are? And be careful when you when you find the dimensions, like where is the base, what is the height, and so on and so forth. Okay, if you have any questions, please let me know. Otherwise, I wish you all the best and hope to see you soon. Bye.